Hello friends, welcome back to my classroom. In this class, let us discuss about continuous probability distribution. So first of all, let us understand what is continuous random variable is. Uh, when a variate x takes every value in an interval, then it is called as continuous random variable. Say for example, I am taking the interval 3, 7. Suppose x takes only the values like 4, 5 and 6. Then this is called as discrete random variable. What we have studied in our earlier classes. Discrete random variable. But when x can take any value between 3 and 7, it could be 3.1, it could be 3.6, it could be 4.8. Okay. So any value between 3 and 7. Then the random variable x is called as continuous random variable. And the corresponding probability distribution is called as probability density function here. So f of x, it's denoted by either p of x you can denote, or it's usually denoted by f of x. So f of x is called as probability density function. And this is called as valid probability density function if it satisfies two conditions. One is this. So when you integrate f of x from minus infinity to plus infinity, it should give you the value 1. Unless it's 1, this is not a valid probability density function. So you might remember, in case of discrete probability distribution, we used to have this condition: sum of all probabilities is equal to 1. Similarly, for continuous random variable, we, instead of summation, we use integration. So in case when we integrate the probability density function, it should give you the value 1. And also f of x must be non-negative for any value of x. Okay, if it satisfies these two conditions, then it is called as valid probability density function. Now the question, how to evaluate the probabilities? Say for example, I have a random variable x and I want to find the probability between 3 and 6, let us say. I want to find the probability that x lies between 3 and 7. So here in case of discrete random variable, we would have added p of 4 plus p of 5 if 4 and 5 are the values that x takes. But in case of continuous probability distribution, we will not add these, because there are infinitely many numbers between 3 and 6. It's not just 4 and 5. So what we do is, to find the probability of 3 less than x less than 6, we integrate the probability density function. We integrate f of x. So we integrate f of x dx, and since we want the probability between 3 and 6, we integrate and apply the limits 3 and 6. So suppose we have uh, uh, after integrating this, suppose the integration result is capital F of x, then we apply the lower limit and the upper limit. Of course, you all know, first we need to apply the upper limit. So first we will put f of 6, then minus f of 3. So this will give you the probability that x lies between 3 and 6. Okay. Now, once you have understood the concept of continuous random variable and continuous probability distribution, let us discuss about the mean, variance and standard deviation. So in case of the continuous probability distribution, to find the mean, we integrate x into f of x. You can relate this with the discrete case also. To find the mean, we used to do the summation of x into p of x. Here it is just integration of x into that function. P of x you can call, or you can call it as f of x dx. minus infinity to plus infinity. So whenever you want the mean of the continuous probability distribution, you just have to integrate x into f of x from minus infinity to plus infinity. And variance also similar to the case of discrete. There we used to do the summation of, for variance we used to do the summation of x square p of x, I mean xi is minus mu square. Here instead of taking the summations we integrate. So what will be the variance? Variance will be integration of x square f of x dx minus mu square from minus infinity to plus infinity. Or you can use the other formula, x minus mu whole square f of x dx. In the, suppose you use the other formula, you will not subtract my mu square, you just integrate it and leave it there. Okay. And as we have already discussed, in discrete case the standard deviation will be square root of the variance. Okay. So it's similar to the case in discrete. It's just instead of summations we do integrations here. Okay. So let us take couple of examples. So first let me take this problem. A random variable x has the density function e power minus x whenever x is greater than or equal to 0 and 0 whenever x less than 0. So my job is to show that f of x is a valid probability density function. So when do we call it a valid probability density function? This function, when I integrate, it should give me the value 1. Okay. So now f of x I want to integrate. So from where to where I integrate? I integrate from minus infinity to plus infinity. E power minus, sorry, not e power minus x. So initially it is f of x dx. I need to integrate this and I have to show that the value will be 1. So minus infinity to plus infinity I am integrating, but f of x is not same for minus infinity to plus infinity. For negative values it is 0 and for positive values it is e power minus x. So integration I will split. So what's happening? Minus infinity to plus infinity I need to integrate. So minus infinity to plus infinity I need to integrate. In the center 0 will be there. So minus infinity to 0, our function says it is 0, and 0 onwards, 0 to infinity it says it is e power minus x. So on the same on the basis of same thing, I'll split this integration. So minus infinity to 0 I will integrate first, plus 0 to infinity. Okay. So whatever may be the function, if whenever you have the split like this, you can split the integration also accordingly. Okay. So here I need to integrate 0 because minus infinity to infinity the function is 0, but 0 to infinity the function is e to the power minus x, and I need to integrate this. Now what will I do? Integration of 0 is 0 plus integration of e power minus x. E power minus x, of course, if you have forgotten, I'll just write it here. E power kx. Integration will be e power kx divided by k. So when you differentiate, it is e power kx into k, but when you integrate, it is e power kx divided by k. So here minus 1 is playing the role of k. So it is e power minus x divided by minus 1. Divided by minus 1 or multiplied by minus 1. It's one and the same. And integration is completed. I just have to apply the limit from 0 to infinity. So first I'll apply the limit infinity. I am putting infinity in place of minus, in place of x. So e power minus infinity minus, because I am subtracting for the lower limit and one more minus is there here. So minus of minus is plus. E to the power minus, in place of x I am putting 0 because 0 is the lower limit. 0 I am putting. And e power minus infinity value is 0. Okay. Plus e power 0 value is 1. So final result is 1. So this proves that the given function is a valid probability density function. Okay. Similarly, whenever you want to check any function, whether it is valid probability distribution or not, you just have to make sure the function is non-negative, and when you integrate from minus infinity to plus infinity, it should give you 1. Okay. So let's take quickly, let's look into one more example. Here, what is given, they have not given the function clearly. Instead, they have said p of x is kx square from 0 to 3 and 0 otherwise. Okay. So 0 otherwise. So first job, I need to evaluate k, and after that need to find some probabilities, and finally we need to find the mean, variance and standard deviation. So let me take the questions one by one. First job is to evaluate k. So what is the idea? We know that when I integrate minus infinity to plus infinity, the function given, it must give me 1. Okay. So here I'll use the same, I'll just substitute p of x. So p of x, of course, everywhere 0 except 0 to 3. So minus infinity to infinity, I can just replace it by 0 to 3, because everywhere else it is 0. 0 to 3 kx square dx, and this should be equal to 1. That's what the condition for valid probability density function. So k is a constant that can be taken out, and just x square needs to be integrated. And what is the integration of x square? Let me uh, just write the formula for x power n dx integration. X power n dx integration is x raised to n plus 1 divided by n plus 1. That means you are just increasing the power of n by 1. Here 2 is the power, so when I integrate, it will be x power 3 divided by 3, and limit is from 0 to 3, and this must be equal to 1. So now what I need to do is, I'll take it to the left of it. This I'll erase it. So now I will try to, okay, I'll apply the limits now. Okay, to get the value of k, I need to simplify this first. So x is the variable where I need to put upper limit and lower limit. So k is there. Okay, x power 3, upper limit is 3, so 3 power 3 divided by 3, minus lower limit is 0, 0 power 3 divided by 3, that must be equal to 1. So this implies k into 3 cube is 27 by 3 is 9, 9 minus 0 equal to 1. So what will happen? 9k is equal to 1, which means k is 1 divided by 9. Okay, so very easy. Just you just have to integrate and equate it to 1, and then if you simplify, you'll get the value of k. Okay, so that completes the first one. K value is 1 by 9. Okay, so now let me take the second problem in this, where I need to find some probabilities. Okay, let me explain one by one. So first probability is to find p of x less than or equal to 1. So sorry, yeah. P of x less than or equal to 1. So what does it mean? P of x less than or equal to 1. Less than or equal to means all the values that are less than or equal to 1. So the number line starts from minus infinity to plus infinity. So minus infinity to plus infinity, somewhere 1 will come. So less than or equal to 1 means minus infinity to 1. So this will be minus infinity to 1. p of x dx. This is what I need to integrate and apply the limits. But p of x is not same for from minus infinity to 1. Only from 0 to 3 it is kx square. Before 0 it is 0. So up to 0 it is 0. So let me write it once again here. Minus infinity to plus infinity is there. I need to calculate less than or equal to 1. But up to 0 this value is completely 0. So less than or equal to 1 means 0 to 1 only we have values. So this will be 0 to 1 kx square dx. Okay, so kx square dx. So kx square integration is kx power 3 by 3 and limit is from 0 to 1. So when I apply the limit, I will have k into 1 cube by 3 minus 0 cube by 3. So it's 1 by 3. So k into 1 by 3 is k divided by, okay, sorry, when I put the value of k, k is 1 by 9. So 1 by 9 into 3 is 1 by 27. So 1 by 27 is the value of k. Sorry, not k. Probability that x less than or equal to 1. So let me take the second problem. Second problem is probability from 1 to 2. So I will not repeat the integration steps again. So these are all same, only applying the limit is different from 0 to 1. Instead of 0 to 1 we have 1 to 2 now. So kx cube by 3 is the integration, so that we can see here because previous steps are same, kx square. So when you integrate kx cube by 3 and limit is from 1 to 2. So what will happen? K into 2 when you apply upper limit, 2 power 3. In place of x you are putting 2. 2 power 3 by 3 minus lower limit is 1 power 3 by 3. So this will be k into 8 by 3 minus 1 by 3. 7 by 3 and k value is 1 by 27, sorry 1 by 9. So 7 by 3 9s are 27. 7 divided by 27. So other values also you can other three problems you can look at them. So other problems also you can solve in the same manner, or you can use the concepts of complements also, or the you can take x less than or equal to 2, and of course you know that p of x less than or equal to 2 you have to integrate from 0 to 2. You can apply the limits. Otherwise, since you have already got x less than or equal to 1 plus 1 to 2, okay, you can add those two probabilities. Why this is so? This is my I have x somewhere 2 is there, less than or equal to 2, that means to the left I have to do. Less than or equal to 1 already I have calculated in the first problem. It's 1 by 27 plus 1 to 2 also I know the probability. So 1 to 2 the probability is 7 by 27. So 7 plus 1 8 by 27. Okay, this is one more way, because previously calculated values also you can make use of them. Okay, so similarly x greater than 1. So x greater than 1, how you can find x greater than 1? It is complement of x less than or equal to 1. Probability of x greater than 1 is 1 minus probability of x less than or equal to 1. So hope you know the concept of complement. So x less than or equal to 1 and x minus x greater than 1, they are complement of each other. Okay, all the values that are not less than or equal to 1, they are greater than 1. Okay, 1 minus and x less than or equal to 1, already you have calculated it as 1 by 27. So when you subtract this from 1, you will get 26 by 27. Okay, and x greater than 3, I'll straight away you know that only 0 to 3 we have kx square. Greater than 3, it is p of x is just 0. So when you integrate 0, you will get 0 itself. Okay, and finally we will see how to find the mean, variance and standard deviation. Okay, for this same function. same probability density function. Let us calculate what is the mean, variance and standard deviation. So I'll take the formula for mean and calculate it. So what is the formula for mean? Mean is integration x into f of x dx. So minus infinity to plus infinity, but again and again I am repeating, minus infinity to plus infinity, p of x is not same. Up to 0, minus infinity to 0 it is 0, and after 3 also it is 0. Only from 0 to 3 we have a non-negative function there. Okay, so this will be 0 to 3 and x is there, okay, let it be, multiplied by f of x. And what is f of x? F of x is kx square. Kx square dx. So when you k can be taken constant outside, and x into x square is x cube dx. And we have to integrate this. Very simple. X cube integration is x power 4 by 4 from 0 to 3. And this is k into upper limit is 3. So 3 power 4 by 4 minus lower limit is 0. So this is k is 1 by 9 into 3 power 4 is 81 divided by 4. So 9 nines are 81. 9 nines are, so 9 divided by 4 will be the mean. Okay. Next, let us take uh, the variance. Okay. Let us calculate the variance. So what will be the variance? Variance formula is integration of x square f of x dx minus the mean square, minus infinity to plus infinity. So similar argument, it will not be minus infinity to plus infinity. Instead it will be 0 to 3. And x square multiplied by kx square. F of x is kx square dx minus mu square. And what is, okay, k is taken out, 0 to 3. X square into x square is x power 4 dx minus mu square. And you can substitute k value if you want now itself. It's 1 by 9. And integration of x power 4 is x power 5 by 5. And limit is from 0 to 3. Minus mu square. Let us subtract it later. Okay. This is 1 by 9 and 3 power 5 divided by 5 minus mu square. And what will happen? 1 by 9 and 3 power 5. In that 3 power 5 actually is 81 into 3. So 243, and when you divide it by 9, you will be having 27 divided by 5 minus mu square. Mu square is what? Mu square, mu is 9 by 4. So mu square will be 9 square divided by 4 square. So you can subtract it and you can get the value. Okay. So final value whatever you get, that will be the variance. And for the standard deviation, you just have to take the square root of the variance. Okay. So hope you understood the concept of continuous random variable and how to find the mean, variance and standard deviation. So this is just a simple example to understand the concept, but for practice you have to work with similar examples. You have to take different functions, different probability functions. Okay. uh, and in the next class we will discuss about exponential distribution. Okay, this is exponential distribution is one of the continuous probability distribution. Okay, thank you.